My name is Matthew. I am a senior architect with Percona, as well as the lead trainer. We do private trainings on site, so if you want to get more than what's going to be tar ball compressed into your brain in the next 25 minutes, we will be glad to, I will be more than glad to come out to your office and train your entire team on everything MySQL related, everything from query optimization. I actually pared this down. This actual chapter is about 250 slides when you get really deep into query optimization, and I pared it down to about 74. I wanted to get the best stuff for you guys in this 101 track. We do everything from high availability, Percona XtraDB cluster. We have actually a MySQL for Oracle DBAs track that if you're an Oracle guy, we teach you how MySQL works from an Oracle DBA's perspective. I'm going to go a little bit more in depth in a couple of things that Michael was talking about as far as how to optimize our queries with indexes. Go over a little bit about query planning, just briefly. What is explain? Michael mentioned this briefly. I wanted to get more depth into that because that's the number one tool that any MySQL DBA or developer has at their disposal to find out whether or not a query is essentially good or bad, or is going to take a long time, or is really efficient, right? I'll talk briefly about composite indexes if we have time, and then the last section here I just labeled the kitchen sink because it's just everything else that kind of was a little dispersed. There's this is actually supposed to be 8 separate sections, but for a time I had to kind of par it down. So what's the number one goal in MySQL? Fastest query, right? They always say the fastest query is one that you didn't actually execute. And if you understand that joke, go look for, I can't think of his name. It's called the Yes Mark. It's a benchmark by Jeremy Cole. It's on GitHub. All it is select one. And it's just like how fast, it's a joke about how fast can you benchmark your machine. Well, if I run select one, I can do like 1 billion queries per second on MySQL. So that was the joke, right? As opposed to other database systems out there like Oracle, MySQL will only tell you about what it knows. Okay, so the way that we do query optimization inside MySQL is I type my query and I ask MySQL, what are you going to do with this query? And MySQL says, I'm going to do this. And then it's your job as DBA, as developer, to say, I don't like that answer, or that's a pretty good answer, sweet, right? If you don't like the answer, it is then your job to make a change, whether to the query itself by rewriting it, or make a change to the schema by either changing some of the column types that Michael mentioned or changing indexes, adding, dropping, and then asking MySQL again, I've made this change, now what are you going to do? Hopefully MySQL gives you a better result and you continue on. And you just repeat this process over and over for your entire application, right? It all starts with this keyword, which is explain. If you want to read this page in the manual, it goes way, way, way deep in depth. I'm going to touch a lot of the highlights. This is the sample database that I'm going to use. Everybody here familiar with IMDb? Everybody been to it? You can actually go download their entire data set off their FTP. What is FTP? Right? Off their FTP website. It's flat files, believe it or not. You download flat files. You use this tool that's on SourceForge. What is SourceForge? And then you can convert it into a MySQL database. And when we do our trainings on site, this is the sample database that we use. Everybody gets instances, and we run all these exercises together. But again, time, we don't have that. This is the table we're basically going to be talking about. It's a very simple table. It has all of the title information for all the entities that are inside this database system. I want to point out just a couple key things here. We have a primary key. We have a title that is a text column. And then we have a whole bunch of other stuff that we're actually really not going to talk about. Okay? Just wanted to point that out, though. So how do we access some data? I want to select ID, title, and production year from the title table where title equals Bambi, order by production year. That's my query in my application. MySQL, how are you going to execute this? All I do is I put the keyword explain in front of that query, and MySQL says, I'm going to do this, right? Well, what does this mean? This is the important stuff to know about what explain says to you, okay? We got a select type. This is a simple select. We have a couple others out there, derived, union, so on and so forth, some of those. Which table is this particular query dealing with, right? What type of access pattern is this? What does this say? It says all, which means I'm going to read every bit of data inside this entire table and then give you an answer, right? Which possible keys could this query have used? If I had some, I don't have any on this table, so it's null. Which key did I use? Which key length, how far into that index did I have to go? That's important when you're diagnosing multi-column indexes, right? We'll talk about ref briefly, and this is an estimate of the number of rows that this query was going to have to touch, right? What is that? 3.3 million rows, right? And then the extra column is basically everything else that they couldn't shove into something standard, right? Also, if you're not familiar with vertical output in the MySQL console, that's where you get \G. You'll notice there is no semicolon. It's just instead of the semicolon, we use \G, and that gives us vertical output as far as horizontal output. It's a personal preference, whatever you feel like doing. So, nobody noticed, I have a warning on this explain. This started in 5.7. What does this warning mean when I said explain? This is actually what the query optimizer, how it rewrote your query internally. And this is how it examined it. So this gets more important in joins, when I have more than usually 2 tables too that I'm joining. And then MySQL will reorganize the order of your tables depending on the indexes that you have and the data that you're looking for. So just if you ever get something weird that you're not expecting out of a join, show warnings will see, oh crap, MySQL's put in the wrong table in the wrong order. I've got something weird going on, right? So I just wanted to point that out, that this now happens by default in 5.7, right? I'm not going to show you the show warnings for the rest of these because I have all simple queries. So what's the rule? When I want to access my data in a more efficient manner, we need to add an index, right? We're going to add an index, usually by default on my equalities, okay? That's the first one that we're going to add. So that's on the title column. I can't do that right easily because what's the maximum size of a text field? Does anybody know offhand? There you go, 65,535 bytes. Well, InnoDB has internal limitations that says we can't create indexes that big. So a really cool feature of MySQL, if you did not know that, is that we can artificially create prefix indexes by specifying how many characters inside this column we want to create an index based on, right? So I'm going to create an index on the title column of the first 50 characters. So I asked MySQL, what are you going to do with this query? It said, I'm going to full table scan 3.3 million rows. I said, that's not good. I made a change to the schema, and then I asked MySQL again the same question. What are you going to do now? Now MySQL gives me a much better result. I'm happy with this, and I can continue on. Does this make sense? Does this process make sense?
Why is there still a warning?
The warning will always be there. So we'll get to that in a second. But the warning will always be there in 5.7. It's always telling you how it's rewriting your query. It'll probably be the exact same as the previous slide, but it's always there now. Yeah? Find a seat. Plenty of open ones. So what changed? What's the biggest thing that changed? Number of rows. Instead of looking at 3.3 million rows, I'm now looking at 4. And instead of a full table scan, I'm now doing what's known as a referential lookup. Oh, that's my reverse firewall. I swear I turned that off. Sorry, guys. Sorry. Okay, continue on. What's another way of accessing this table? Primary key. Okay, primary key is the fastest way you can look up any InnoDB table because the tables are on disk in order by primary key. Okay, so you can't go anything faster than that. How would you get the primary key? Usually a cache. Right? If you already did some other complex query or you have somebody logged in and you've got their ID cached somewhere, then you can just look that up by primary key, right? Simple enough. This is another way of accessing rows using like and pattern matching. Okay? So this says select all this information where title is like BAMB %. Everybody is aware that the %, is MySQL's string wildcard, right? Right? If you weren't, you are now. Right? So this is a range scan. Why is this a range scan? Does anybody know? Yeah, this isn't looking up one simple value. This is actually looking up everything between BAMB AAAA through BAMB ZZZZZ, right? So we're looking at a range of data. So that's why this is considered a range, right? How many of you are familiar with what a B tree is? Everybody familiar? Okay, good. Yeah, it was really weird the first time I hit computer science and we were actually talking about self-balancing B+ trees in my computer science class. And I started learning about MySQL after I learned that. And at some point I was like, well, wait, when does InnoDB redo its balancing? And I was unaware that my college professor never told me that there's more than one type of B tree out there. So I was like, oh, okay, so simplified, right? We're not going to talk about some of the other indexes that are available because there are plenty of other ones that are available out there. Even if you yourself want to make your own indexing solution for MySQL, yay, MySQL is a pluggable architecture, so go write your own, load it into MySQL, and then you could be the next, I don't know, keynote speaker because your index is awesome, right? The one thing about all B trees is they all have a point of entry, the root node. And when you hit that root node, you have to decide, do I want to go left or I want to go right? Okay? Well, if we were looking for Bambi, B-A-M-B, wildcard, we basically say, is that less than K? Go to the right. Is it greater than or less than C? Go to the right. Greater than or less than A? Go to the left. And then here's all of our leaf nodes that contain all of our data. So we can look at that small range scan of data. Make sense? Yeah? How about this one? And I put this one in here. Oh, he put a thumbs down. I like that. So this slide is in here because you would be surprised as a consultant how often we get people who say, I have an index on the title table, on the title column, but it's not being used by my query, and this is their query. Right? Why is this doing a full table scan? I don't have a starting point. You guys are smart. Good grief. Why are y'all in here, right? We don't have a starting point. Remember I said all B trees have a root node, and you have to decide, do I go left or do I go right? In this case, the answer is yes, right? I have to because I've said start with wildcard, right? Where do we actually see this happen the most is systems that are storing email addresses. And they want to say select star from table where email like %@yahoo.com, right? Is the biggest place that we get that. Quick freebie note, if you want to do something like that, do you know what the trick is? Store it backwards. Whether you just reverse the entire string itself or you store com.yahoo at, and then you can do properly indexed wildcards. It's a freebie. I throw out freebies. I don't throw out swag, I throw out freebies, right? What about this one? The next two slides are a very common case that we get as well. Okay? This says select star from title where title is like Z%. Okay? It's a range scan. It doesn't start with a percent, so we at least need to know whether or not we're going left or right, correct, from the root node. And we're looking at about 25,000 rows. I'm going to change one thing about this query, and this query is going to go crap. What did I change? I changed from Z% to T%. We get this a lot in the consulting industry as well. I tested this query and it was great, and then I put it into production and it went to crap. Anybody have a guess? This is where data becomes a humongous part of what you're querying. There are far more movies, TV shows, video games that start with T that start with Z. So you may be testing the Z% case in your application, in your QA environment, and then you deploy the code, and the first person to hit your website, your application types, I want to know everything that starts with T, and everything goes to crap, right? So MySQL is reasonably smart, right? There are hundreds of people over at Oracle that are working on the query optimizer, code that I don't ever want to touch or look at, right? Unless I want to go to sleep. So the optimizer's job is trying to decide which indexes are going to be useful, which indexes you have that want to be avoided for that particular query, right? We talked about the phone book issue, right? This is how B-trees, how indexes are helping us scan the information that we do or do not want to see. The optimizer is playing this little cost game internally. And it's basically saying, how much data am I going to have to look at if I use your index? How much data, versus how much data would I have to look at if I full table scanned? Okay? So if I'm only going to look at, what is that, 0.1% of the data, I should use the index because that'll be cheaper. At some point, however, when I get to the maybe 90, the number is a wild card and is calculated with heuristics and algorithmic expressions inside the optimizer code that I don't ever want to read or touch. somewhere in there, the optimizer says, you know what? It is more expensive for me to read all of this data out of the index and then go and read all that same data out of the data. So instead of doing a two-step operation, the optimizer says, screw it, let's just full table scan. We need the data anyway. We're going to read just a few extra rows, right? Essentially, that's what happened with this case. In the Z% case, we were down here. So it's cheaper to use the index. But then when we got to the T% case, we're going to have to read a whole lot more data. MySQL just said, you know what? It's cheaper to just go ahead and full table scan, right? So consequences of the query itself and what data you're providing to that query. So this is where we say your testing is critical. Make sure that you're testing with real-world values that people are actually typing in on your application. You know, they always make the joke about this wasn't designed by a marketing person, this was designed by an engineer, right? So make sure that you're testing data that your real-world people are doing and not what the engineers are typing in, right?
Is there a simple way of blurring the real data?
Yeah, Apache logs. I mean, in all seriousness, I mean, like, I'm assuming you're running Apache or some kind of Nginx that logs what the query string is every time somebody types it, and you can go over to my friends over at Elasticsearch, and they'll absorb all of those logs for you, and then you can run and say, what are the top 5 query strings in our application? And they'll just pull that out, and then you can test with that, add it to your smoke test, yes?
I would recommend the slow log. I was just going to say anything more fancy than this.
Let's say this slow log will work just as well. I like pulling from the application, but yes, the same stuff will come from the slow query log as well. Correct. Anything that's using that PMM, Percona monitoring and management, will be able to absorb that as well as PT Query Digest. Absolutely. Yeah? Oh, she came in with the 10-minute card. I know, and I still have 80 more slides left to go. So, sorry. You're going to get all these slides, by the way. Oh, now she says 5 minutes. Okay. Okay. Yeah, so this basically, the slides that I'm skipping, I was just basically going in order of fastest query types to longest query types. I'll tell you the 2 most common ones that you will see, queries like this that are an index-only scan, right? So I'm full table scanning just the index B tree. Does that make sense? It's still faster and less intensive than a full table scan because I'm looking at less data, right? And then, of course, we know the infamous all, right? Just to point it out, this is another common type of query that we get as consultants. Assume that I have an index on production year. But this is the explain output. Why? You were too fast. You gotta let people think, man. He is absolutely correct. For those of you who are unaware, MySQL is unable to use an index when you pass it through a function. Okay? I believe, and somebody quote me if they know this better, that the only database system out there that can do this is Postgres. But you can only do indexes on a function when all of the parameters are exactly the same, right? Otherwise, we can't do that, right? This is the correct way to write this query. And this turns into another freebie that says, if you are manipulating the data that's stored inside your database, you're storing the data wrong, right? You should never manipulate or mangle the data that you're storing in your database to match the user input. You should mangle user input to match your data in your database. Because again, if you're not, that means you're storing the data wrong, right? There's going to be more stuff about what is inside the extra column. My favorite question, this is an interview question. If you ever want to come interview with Percona, Peter always asks, what does using file sort mean? Wrong. It does not mean a file on disk in any way, shape, or form. It is one of the greatest mislabeled error messages in MySQL. It has absolutely nothing to do with files. What it really means is bubble sort or quick sort. I don't know why it doesn't just say using quick sort. Somebody file a bug and we'll all go say affects me, right? And maybe they'll relabel it. What it really means is that when you have an order by that has no index on that order by column, MySQL internally has to do a quick sort on your result set to order that extra stuff. And every time it has to do a pass by of quick sort, this counter is incremented and it says using file sort. It's not even creating a temporary table. It's all just memory buffers. That it's just doing a little bit, memory buffer, a little bit, memory buffer, and then sending you the result sets as they come in. Yeah, it's totally expensive, yes. It's totally expensive. And you can watch the counters on that as well to see how scale-wise. You can see using file sort on your query and then look at the counter, maybe it incremented by 2. That's not that big a deal. You can run your query using file sort, shoot, and go look at the counter, and it's 486 million. That's bad. There's always scale in everything with MySQL, yeah. MySQL is very, very explicit these days on whether or not it will use a temporary or use a temporary on disk. It will explicitly say whether or not it's doing so. Oh, geez, I want to talk about composite indexes. I'm sure I'm way off on my time, because see, we were going to go through all of this stuff. We were going to do it the wrong way first because it's a class, and then we were going to do it the right way. I will point out here real quick that in this particular case, this query that I want, which is select title, where title equals pilot and production year is between these 2 years, that a composite index is the best use case for getting this data out. Sure, we can have an index just on title, but that's going to be pulling all of the data out of the engine where title equals pilot into MySQL, and then MySQL will be doing extra steps to apply the rest of that, which says filter out everything between the 2 production years. Right? So if we can ask InnoDB first, give me everything, title and production year, it's less CPU, it's less intensive for MySQL to have to do any extra steps in processing those result sets. And it kind of looks like this. There's also, we go over choices between, do I do my composite index of production year title, or do I do over to title production year, right? This is what my B tree would look like if I did production year title. I'm doing random jumps, you can see, to find everything that's for pilot. If I do it the other direction, everything is already grouped together for me and sorted. So it's way more efficient to do title production year that way. And this goes back to something that Mike said about always wanting to make sure that our indexes are built in left to right order, hitting equalities first, and then keeping all of our ranges to the end of the index. Yeah? And even still, if you have multiple equalities, you need to pick the equality that's going to filter the most amount of data as your first column, and then the next one, and then the next one. Right? That's basically what those say. And then the kitchen sink. Indexes are multi-purpose, so don't forget that. They do have overhead. You'd be surprised. I don't want you to go back to your systems and call us in a month and say, we need an audit because something's wrong, and we get on your machine and you've indexed every single column. Don't do that, because I'm not saying that. Don't leave this conference and say, Matthew told me to index every column. I'm not saying that. Right? Because as Mike said, every single insert, every single update, every single delete on your system must lock and update every single B tree for every single index that you have. So if you have an index on every single column on your system, that's way too much intensiveness. Yeah? Only keep the indexes that you need. This is going to go over basically having our title production year index and how this will prevent our file sort, because the index is going to be useful for finding title, because of the title, and then also going to be useful in ordering our production year. Right? So we see no file sort here. Make sense? I know this is tarball compressed gzipped into your brains right now, and you're going to slowly extract it all out. Yeah? Here's one that's doing a temporary table. It actually says temporary. Look, there's the dreaded file sort. And then once I put, this becomes an index-only scan. Right? I'm doing count star, production year, group by production year. So I'm basically saying how many of everything came out every year. Right? And this is an index-only scan of 3.2 million rows. Yeah? So they're multi-purpose. The same thing here. We can mess with less memory, less buffer pool utilization. If I'm doing select person ID from cast info where person role ID equals this, there is a big difference between an index just on this, which makes sense because that's the rule we've been following. But what if I created an index on person role ID, person ID? Right? Right? It's a little bit better because I'm going to be looking at less data. Whoop. Yeah. questions? Probably 3 minutes over time, but you guys are engaged and you would rather be here than go eat, right? Like I said, I'm Matthew. This is Mike. We do on-site training. We do audits. So if this is all very confusing to you, we can come out for several days, train your whole group. If you want an audit, all of the queries that Mike talked about with top table size, index usage, index fractionalization, we do all of that for you, give you a really nice output, discuss what's going on with your system, suggest changes, improvements. We look at your top worst queries, suggest performance improvements there as well. So don't be afraid to stop by the Percona booth and talk to somebody there about having us do an audit for you. Cool? Thanks for coming. Go eat.